Are you struggling with type parameters and inner constructors in Julia 0.6? You're not alone. Today, we're diving into a common issue that many developers face when working with parametric types and abstract types. I understand how confusing it can be when your code doesn't work as expected, especially when it comes to type restrictions. This is a common hurdle for many Julia users, and it can be frustrating when you just want your code to run smoothly. Let's look at the specific question at hand. One user asked about restricting type parameters for parametric types with abstract types in Julia 0.6 using the where syntax. They provided an example that didn't work as intended. Sound familiar? Let's explore this together. So what's the issue here? The user tried to define an abstract type with a type parameter restricted to integers using the where syntax, but it failed. This can be tricky, and understanding the nuances of Julia's type system is key to resolving it. And stick around. By the end of this video, you'll have a clear understanding of how to properly use type parameters and inner constructors in Julia, plus a bonus tip that will make your coding life easier. To define a parametric abstract type that restricts its type parameters to integers in Julia 0.6, the user should use the non-where syntax. This means the correct way to declare the abstract type is by writing abstract type, abstract foo t integer end. Next, when implementing a subtype of this abstract type, the user can also use the non-where syntax. The correct way to define the mutable struct is mutable struct foo t integer, abstract foo. This ensures that t is restricted to integers. Regarding the inner constructor, the user is correct that the deprecation of the inner constructor syntax makes it challenging. However, the user can define an outer constructor to achieve the desired functionality. This can be done with foo_xt, where t equals foo t x. In summary, the user should use the non-where syntax for both the abstract type and the subtype. Additionally, defining an outer constructor is a suitable workaround for the inner constructor issue. Fun fact, Julia was designed for high-performance numerical and scientific computing, but it can also be a bit tricky when it comes to type systems. Just like learning to ride a bike, it takes practice, but once you get it, you'll be flying. Now, let's look at the answers provided by other users. An alternative approach suggested by another user involves defining the abstract type and mutable struct as follows. First, they recommend using the non-where syntax for the abstract type, which restricts the type parameter to integers. Then, for the mutable struct, they propose defining an inner constructor that allows you to create an instance of foo using just an integer, like foo2. This method effectively limits the input to integers while maintaining usability. Regarding the questions, the user confirms that this is indeed the correct format. They also note that while the struct definition is valid, it may lead to confusion due to error messages arising from the abstract type. Lastly, they clarify that the introduction of the where syntax was intentional, allowing for more flexibility in defining constructors outside of the type definition. Let's move forward and look at another answer. An alternative approach suggests defining the abstract type without restrictions on the type parameter. Instead, restrict the parameter in the concrete type. This user proposes defining the abstract type as abstract type abstract foo t end, and then creating the mutable struct foo t integer abstract foo t to enforce the integer constraint. Here's a pro tip. Always check the latest Julia documentation for updates on syntax and best practices. The language evolves quickly, and staying informed will save you a lot of headaches. And there you have it. You now have the tools to effectively use type parameters and inner constructors in Julia 0.6. If you found this video helpful, please subscribe for more coding tips and tricks. Happy coding!